Hello and welcome back. We have understood decision trees at a high level. With an example, let us try to understand how exactly the decision tree algorithm works and creates that tree structure. So I have taken a simple data set with outlook, temperature, humidity and wind as input and play tennis as output. This is historical data. When a new record comes in, we need to predict whether on that particular day people are going to play or not. So before we split the data, right, I said the algorithm will split the data and then check if the subset is pure or not. If it is pure, it will stop splitting. If it is not, it will repeat the steps, right? So before we split the data, we need to understand on which column to split. We have outlook, temperature, humidity and wind. We need to understand on which column we should split it. So to measure that and decide on which column to split, we have algorithms: Gini index, information gain and gain ratio. These are called as impurity measures. When Gini index or information gain, the impurity is low, that's the column we should split the data on. So if the impurity of outlook is low, we should split the data on outlook column. If the impurity of temperature is low, then we need to split data on temperature column. If impurity of humidity is low, we should split the data set on humidity. So that is these formulas, the Gini index, information gain and gain ratio are the formulas which give us clarity on which column to split and proceed, right? So that is one point. On which column to split we need to decide. That's one point. And the second point is the algorithm which we are using, ID3 or CART. So there are two algorithms to split data. So CART algorithm actually does binary split like this. Binary split means on a given condition the data is split into two parts only. ID3 algorithm does multi-way split. When I say multi-way split, based on a given column it will do more than two splits. So that is multi-way split. So for explanation purposes I have chosen ID3 algorithm, but in scikit-learn it uses CART algorithm to split the data. Anything is fine, just need to understand how exactly the algorithm works. So there are formulas for Gini index, information gain and gain ratio. For Gini index, to calculate the Gini index for the target variable, this is the formula: 1 minus sigma t is equal to 1 to k pt square. That is, if there are k number of classes in your data set, here in this case 2 classes, yes and no, and to calculate the impurity or the Gini index of the target variable, it is 1 minus probability of s square minus probability of no square. Probability of s square is probability of s is there are 14 records and 9 belongs to s. 9 by 14 is the probability. And for the no probability there are 5. So 5 by 14 is the no probability. So 1 minus 5 by 14 minus 5 by 14 square minus 9 by 14 square. This is the formula to calculate the impurity, Gini index of the target variable. To calculate a given input column's Gini index, we need to use this formula: sigma probability of v into sigma I is not equal to j probability of I given v probability of j given v. Here v is the value in the attribute. If you take outlook, the attribute or value here is sunny is one value, outlook overcast is another value, rain is another value. If you have to calculate probability of outlook, right, probability of outlook, our Gini index of outlook, you need to calculate probability of sunny into probability of yes given sunny and no given sunny, plus we have a sigma here, right, probability of overcast into probability of yes given overcast into probability of no given overcast, plus probability of rain into probability of yes given rain and probability of no given rain. So if you look at this formula, there is sigma on all the values in that particular attribute A, all the values in that particular attribute A, and probability of conditional probability of the attributes value, the probability of yes given attributes value and probability of no given attributes value, probability of class given attributes value and probability of class given the other class the value given. So like that you need to calculate probabilities. So if you look at formulas one more time, right, you will understand. So impurity measure, this is Gini index is one impurity measure, information gain is another impurity measure, and gain ratio is another impurity measure. Information gain is nothing but cross entropy. We have seen cross entropy in softmax regression classifier and logistic regression. It's a cost function, right? So the same formula here. So if you look at the calculation here, Gini index for ID3 algorithm we are doing, and Gini index for play tennis we calculated, and it is 4.4593. Target variable Gini index is needed to calculate Gini gain. Impurity is less, gain is going to be more. So I'll show that in a moment. So Gini index of outlook is probability of sunny into probability of yes given sunny and probability of no given sunny. Probability of sunny is what? Out of all the values, how many are sunny? Right? It is 5 by 14. If you see this, 1, 2, 3, 4, 5, and total number of records are 14. Probability of sunny is 5 by 14. And then probability of yes given sunny. So sunny no, sunny no, sunny no, sunny yes and sunny yes. So there are two sunny days which are yes. You know, when it was sunny, only 2 days they were playing. So yes given sunny, they are playing given the day is sunny, is 2 by 5, because total 5 sunny days are there, out of which 2 days they played, and no is going to be 3 by 5 only, 1 minus p, right? Only 2 classes are there. If you find p, it is 1 minus p only. And for the next the overcast, in the same column, overcast, how many overcasts are there? 1, 2, 3, 4. Out of 14, 4 are there. 4 by 14 is the probability of overcast into probability of yes given overcast and probability of no given overcast. If you see this, overcast yes, overcast yes, overcast yes and overcast yes. All 4 days they are playing. When it is overcast, it was overcast, right? They are playing. So that means 4 by 4 is the probability. Probability of yes given overcast. Probability of no given overcast is 0 by 4. But the third one, probability of rain. How many rains are there in this column? 1, 2, 3, 4, 5. 5 by 14 is the probability of rain. And probability of yes given rain, 1, 2, 3. 3 days they were playing when it was raining. Right? 3 by 5 and 2 by 5. Out of 5 rainy days, 3 days they played, 2 days they did not play. So probability of yes played given rain is 3 by 5. Probability of no not played given rain is 2 by 5. So that's how you calculate probability. So you multiply these and sum up, you get 0.1714. And probability of temperature, same way. In the temperature, you know, probability of hot is 1, 2, 3, 4. 4 by 14. And out of 4, no, how many yes, how many no's? 2, 3. Yeah, 2 s's and 2 no's. So 2 by 4 and 2 by 4. You know, this is 2 by 4 and 2 by 4. So you need to calculate the probabilities. The algorithm will calculate the probabilities like that. And Gini index we have got 0.22. That means outlook is purer compared to temperature. When I say pure, impurity measure it is. Impurity it is showing. Impurity is low, impurity is high. On the third column, the humidity, the impurity is, you know, even a little low, but you know it is not lower than the outlook. Wind impurity is high. Out of all 4 columns, impurity on wind is high. That means least preferred column is wind and best preferred column is outlook. We can split the data on outlook. So if you look at this, this split, on outlook we split it. Outlook is equal to sunny, one subset. Outlook is equal to overcast, another subset. Outlook is equal to rain, another subset. Right? So out of these 3 subsets, the outlook is equal to overcast is pure. You see this? All records belong to one class. So you no need to, the algorithm no need to split this subset into further, you know, subsets. So the algorithm for this particular subset stops. this subset and this subset, the rainy and sunny subsets, will still continue. Okay, so if you look at this gain, Gini gain, which is nothing but Gini index of the target variable minus the attribute value, Gini index of the target variable minus attribute value. Gini index is low, gain is going to be high. If you are looking at gain, or the algorithm is looking at gain, the score should be high. If it is looking at the Gini index, score should be low. It's a mathematical trick, right? Gini index is good, right? Impurity measure, impurity should be less to select the feature. So I want to highlight one point here. When we say impurity is low and we are splitting that column, splitting the data on that particular column, that means that is the best feature out of all the 4 features. This is one of the feature selection approaches. In random forest, we will see that again. We'll actually talk about this again. This is one of the feature selection approaches. Out of 4 features, we selected one feature to distinguish data or split the data. Okay, so we'll see further steps also in coming session and see the ultimate resultant tree and try to make predictions using that tree. Thank you.